All right, let's get right into it. So picture this. You've got a legendary mathematician, a total giant of the 20th century, who leaves behind this mountain of unsolved problems. Then, on the other side, you have a cutting-edge AI, one of the most powerful we've ever seen. This is the story of what happens when that machine tries to climb that mountain.
So, what happens when you pit a super powerful AI against 700 of math's toughest open problems? That's the huge question here. A team of researchers basically unleashed this AI agent to systematically go after 700 unsolved conjectures from the famous Erdős problems database. And this wasn't just some casual test, It was a full-blown experiment to see if AI could really discover new math on a massive scale.
And the challenge itself, it comes from Erdős, who is, one of the most prolific mathematicians ever. He left behind this incredible legacy, hundreds and hundreds of unsolved conjectures. You can almost think of it like a giant scavenger hunt for mathematical truth, where the clues are just scattered across decades and decades of research.
Okay, but here's a really important thing you got to understand. When mathematicians say a problem is open, it doesn't always mean it's impossible to solve. A lot of the time, it just means you can't find the answer with a quick Google search. This creates this really interesting gray area where solutions might be hiding in plain sight, buried in some obscure paper from way back when. And that's exactly where an AI could have a huge advantage.
So, let's meet our AI hero, if you will. Its name is Erdős. It's a specialized math research agent built on top of Gemini. And its mission was simple but massive. Go through all 700 of those open problems and do the one thing humans struggle with. Process, analyze, and spit out potential solutions at a completely insane speed.
But listen, this wasn't just about letting an AI go nuts on a bunch of problems. No, the process was actually a really smart partnership. First, Erdős would generate a ton of solutions. Then, a second AI, a verifier, would come in and automatically filter all those results, looking for anything that might be correct. And only then, after all that, did a team of human mathematicians jump in to look at the best of the best. It's a true human-AI team-up right from the start.
Okay, and this is where the story gets really, really interesting. Out of 700 problems, how many do you think the AI actually solved? You might be thinking it's a huge number, right? Well, the reality was, this intense filtering process that tells us something fascinating about what these AIs are really good at.
So, we start at the top of the funnel, a massive list of 700 problems, all officially labeled open. Erdős's job? Take a crack at every single one.
All right, first pass done. Erdős's own internal AI verifier makes the first big cut. It just throws out hundreds of attempts that are obviously flawed, leaving 212 responses that it flags as maybe correct. That's a huge drop, but still way too many for people to check one by one.
Okay, now the humans get involved. The experts dive into that pool of 212 candidates, and wow, they find that only 63 are even technically correct. Turns out, a lot of the AI's initial ideas were just plain wrong, or it had completely misunderstood what the question was asking.
And then the final cut. After the real domain experts went through everything with a fine-tooth comb, that number plummeted to just 13. 13 solutions that were actually meaningful and correct. Think about that. We went from 700 all the way down to 13. That is some serious filtering.
So why such a dramatic drop-off? Well, when you look at a sample of about 200 of the AI's candidates, a whopping 68.5% of them were just fundamentally flawed. It just goes to show, the AI was generating a ton of noise along with that tiny bit of signal.
And this really gets us to the main takeaway of the whole experiment. Erdős didn't act like some genius mathematician, having brilliant flashes of insight. It acted more like a research assistant on steroids. It was just an incredibly powerful tool for sifting through mountains of information, spotting existing work, and flagging things that were worth a closer look from a human.
So, what about those 13 that made it through? What did the AI actually do to solve them? The researchers broke it down into this really cool taxonomy of discovery.
Yeah, just take a look at this breakdown. The most surprising thing here? The huge majority of these so-called successes weren't new discoveries at all. Only 2 were genuinely novel solutions. The other 11? They were either partial solutions or, and this is the big one, the AI was just finding answers that were already out there, just lost in the literature or too obscure for people to track down easily.
And you've got to understand the difference here. It's pretty important. In 4 cases, the AI came up with a solution all by itself, only for the human researchers to discover, oh wait, someone else actually solved this years ago. We're calling that independent rediscovery. But in 5 cases, it was even more direct. The AI basically acted like a superpowered search engine and just found the obscure paper with the answer already in it. That's literature identification.
But there was one moment of what you might call pure AI creativity, a genuine spark. It was the solution to problem Erdős 1051. The researchers said the AI's method was totally new. It didn't look like any known human approach. So in this whole ocean of rediscovery, this was one small but really significant moment of actual machine invention. Of course, using these incredibly powerful new tools brings a whole new set of problems. And what this experiment really showed is that the hardest part of doing research with AI often has absolutely nothing to do with the math.
Yeah, the real bottleneck wasn't solving some crazy complex equation. It was all the detective work. The human experts spent most of their time just trying to figure out when the AI completely misunderstood the question, or digging through old archives to check if a new solution was actually just hiding in some paper from 1981. They were constantly wrestling with ambiguous symbols and definitions. This is kind of the hidden cost of collaborating with AI.
And this led them to a really critical warning. See, because these models are trained on, well, basically the entire internet, they can just spit out information they learned during training without telling you where it came from. So it might solve a problem just by perfectly recreating a solution it saw somewhere, but it never cites the source. The researchers have a great name for this: subconscious plagiarism.
So what's the big picture here? What does all this mean for the future of science? Let's put these results into a little context.
So Alethea's 4 genuine contributions, the novel and partial solutions, that's a big deal. But it's also part of a much bigger trend. Other AI projects have already knocked down another 6 of these problems. You can really see a clear pattern here. AI is slowly but surely chipping away at this huge mathematical mountain.
When you boil it all down, this experiment really shows that AI is amazing at grabbing all the low-hanging fruit. Solving the problems that are open, simply because the answer is buried or obscure, not because they're insanely difficult. It's a huge accelerator for science, for sure, but it absolutely cannot do it alone. It still needs human experts to steer it in the right direction, to double-check its work, and to find that one tiny, crucial signal in a giant sea of noise.
So this is where we land. What this all shows is that the whole conversation is changing. It's really not a question of if AI can contribute to science anymore. That ship has sailed. The real question, the one we all have to figure out now, is how can humans, build the best possible partnerships with these new tools to unlock the next great wave of scientific discovery?